Yeah, okay. So tonight I want to talk about herbicide evaluation for registration. That will be the first part. It's a short one. Then probably I will talk a bit on herbicide resistance. So I will just begin by these herbicide evaluations which are done in order to register herbicides. Yeah, in this country, I know that herbicides or any other pesticide has to be evaluated, data has to be collected, and it has to be submitted to the pesticide registrar for processing. Then the pesticide, in this case herbicide, may then be commercialized or sold to farmers. So let me present. Okay, so our topic is herbicide evaluation for registration. Now, if a new herbicide is going to be used, there's basic information from the herbicide technical data sheets which should be noted. There should be proposed rates, the crops where the herbicide is supposed to be used, types of weeds controlled, time of application, is it a pre-plant incorporation herbicide or pre-emergence or post-emergence? This basic information should be available either to the agronomist who is going to evaluate the herbicide. We should also know the chemistry of the product, LD50, indication of its toxicity, its solubility, vapor pressure. Vapor pressure is particularly important because the herbicide may require incorporation. So basic information is usually obtained under glasshouse conditions and need to be verified under field conditions. Most of our herbicides may be originating from Europe, US, and probably now from China. And there's some data in those countries which we need to verify when we bring the products in Zimbabwe. So the first thing when you are evaluating a new herbicide is to develop an objective. Probably the suitable objective may be to determine the efficacy of the new herbicide for the control of weeds. It could be maize or any other crop for that matter. Then, as if you are doing research under materials and methods, you need to select your site, which should have a wide range of spectrum of weeds. You should also capture soil type. Some key weeds need to be planted in the research plots. Of course, we know that sometimes weeds may not germinate because of dormancy. These are some of the challenges to do this work. The crop should be grown at recommended agronomic practices. Now, these are the basic type of treatments which you may want, but probably there could be three. The first one is the new herbicide at the target rate from the chemical supplier. Maybe it's an overseas supplier. Then what you may have to do, you may have to increase it by 10%. That could be your treatment two, or reduce it by 10%. That's your treatment three. Then there should be a standard herbicide, which is used to solve that problem, which you are going to compare its performance with the new product and see which is doing better. You also need a control where you don't put the herbicide. There could be just timely hand hoeing or hand weeding. This will later enable you to determine whether there is a serious phytotoxicity being caused by the new herbicide. Of course, you need a well-designed experiment which is replicated. Normally, standard replications could be 4 times in randomized complete block design. These are the designs which are normally used under field conditions. This could be your plot. You need a gross plot, then a net plot. In the net plot, this is where you sample your weeds in 50 times 50 centimeter quadrats. Now, what sort of data should be collected? Number one, it should be crop phytotoxicity data, and weed control efficacy should be recorded as from 1 week after herbicide application, and you can go on, recording until probably crop maturity. We normally use the EWRC, the European Weed Control Research Council system, which is standard worldwide to assess crop phytotoxicity and weed control efficiency or efficacy. This is an example of the weed scores which are used. If you are assessing weeds, you want to find out whether the chemical can control the weeds. So we have got a rating of 1 to 4, 1 representing excellent weed control and 4 good weed control. 2 and 3 are in between. They are also good weed control. Then we have got the borderline control. This is, it's a control which may be acceptable, but grade 6 is unacceptable. 7, you can see we are in the red. Slight herbicide effect. 8, poor control, and 9, no effects. So it's quite a wide range of scoring. You also have crop scores. 1 to 5 means no phytotoxicity to acceptable phytotoxicity. 6, it's now unacceptable phytotoxicity. 7 to 9, it's serious phytotoxicity. In addition, you also need to take crop data, things like date of emergence, plant population, plant height. You may take photographs, to capture phytotoxicity. Flowering dates, maturity dates, and one of the most important thing will be grain yield. Now, on weed data, you count weeds in 50 times 50 centimeter quadrats, and this should be sampled at 3 positions in a plot. It can be systematic, which is diagonally, or random sampling. Then weed species are to be taken from the 50 times 50 quadrats, and then dry weights are determined. Each individual weed species has to be recorded, because by the end of the day, we want to see the activity of the herbicide across different weed species. Data analysis, we have to subject the data to analysis of variance, probably using available software. It could be GenStat or R. But in most cases, data on weed counts is usually transformed before analysis of variance. But of course, after evaluating it, sometimes you may not need to transform the data. Now, what sort of information do you want to extract from this evaluation? You've got a number of questions. The first one may be, does the new herbicide control weeds better than the standard practice or standard herbicide? So you need a treatment comparison of the new herbicide versus the standard herbicide. Probably this is a key comparison. Now, in varying the uh, by 10%, either going up or down, what sort of comparison can you do? You have the recommended new herbicide versus either the rate which is 10% more or 10% less, to see whether this herbicide is, whether this herbicide rate is stable. Does the new herbicide cause phytotoxicity, which is reflected in the crop yield? Your treatment comparison, this is where you choose the new herbicide versus the hand-weeded treatment control. This will give you whether the herbicide can suppress your yields. So these are some of the key comparisons which you may extract from this evaluation. Now, how long should you do this study? In Zimbabwe, it is recommended that this kind of studies you need to do 3 years of data collection. You also need data on herbicide persistence by growing sensitive crops at the trial sites. You may also take some soil samples from soil sites, and a number of crops could be tested under glasshouse conditions. Probably you want to know how long this herbicide may persist within the environment or within your field. Does it interfere with some crops and so on? These may become a part of your recommendations if it is registered. At the end of the evaluation, you will need, number one, toxicological data. You also need experimental reports, which cover a period of 3 years of data collection, data on weed control efficacy and crop phytotoxicity will be required. The proposed registration label showing how the herbicide is supposed to be used, dosages, crops, and weeds controlled. So this information will be packaged and sent to the pesticide registering officer or registration officer, who is in the plant protection department of the Department of Research and Specialist Services. So sometimes the herbicide will be registered, then eventually it will be used by the farmers. So in this country, all the pesticides have to be registered before they can be used by the farmers. So I'll end here for this one.